See, the meaning of a Fourier series. So Fourier series expansion is used for periodic signal. Okay, means like for determining the harmonics. So in a Fourier series expansion, we actually determine the periodic signals. Fourier series is used basically for a periodic signals. Okay, like if anyone is asking you what is the Fourier series, so in Fourier series is just expand. Okay, in Fourier series signal is expanded is expanded in terms of its harmonics, which are sinusoidal. So any periodic signal can be breakdown in the form of sinusoidal and orthogonal to one another, each other, orthogonal to each other. Okay, with the help of Fourier series, what we can do? So why Fourier series is needed? So with the help of Fourier series, it is possible it is possible to determine what harmonics contain of the signal. So we can easily find the harmonics content of the signal. Harmonics contents of signal. Second one is phase contents of a harmony, means phase value. Phase value also we can determine. Phase contents of a harmonics. And third one is power content of a harmonics. Okay, with the help of this we can also find total power correlations. Okay, total power of the signal, total power of signal can also be determined. And the fifth one is auto correlation of signal. Okay, there was a two conditions for applying the Fourier series, that is known as Dirichlet conditions. Okay, so when we can apply the Fourier series, so Fourier series can be applicable only on if it satisfies the three condition is there, means 3 condition is there. So we will study that condition for Fourier series expansion. So it is nothing but, first is Dirichlet condition, Dirichlet Dirichlet condition. Okay, so what is the meaning of a Dirichlet condition? Signal should have a finite number of maxima and minima. Signal should have finite number of maxima and minima. This is the Dirichlet condition. So for example, you can take it like this, a triangular signal. In this triangular signal, you can see finite number of maxima minima is coming. One maxima, one minima. Like this it's going. So if this kind of a condition is satisfied, only we can apply the Fourier series expansion. Okay, so Fourier series expansion is possible in this case. Okay, what about this case? Example number 2, if I'll give you, see, like this. Again it's it's coming like this. Okay, so in this kind of a case, the Fourier series expansion is not at all possible. Okay, not at all possible. Why so? Because there is a no finite number of maxima and minima, and this kind of a signal is not even not periodic signal. So in this kind of signal, we cannot say the Fourier series expansion is possible. So Fourier series expansion is not possible. Not possible. Because infinite number of maxima and minima is there. What was the conditions for Fourier series? For possibilities, it should have a finite number of maxima and minima. So we are getting a finite number of maxima and minima in particular time period. Okay, so if this kind of a signal will be a periodic also, but suppose this is the time period, this is the another time period, in that particular time period you are getting a infinite number of maxima and minima, then Fourier series will not be applicable to that particular signal. Okay, so over the range of a time period you need to calculate. What about this? If I'll give you this signal, one square pulse is there. Okay, so this kind of a square pulse if we are generating, so so it's like a straight. Okay, let me correct it. This is the, and the time period if you will see 0 1 2 3 4. So here Dirichlet condition satisfied. Okay, because we are getting maxima and minima, finite number of maxima and minima in particular time period. Okay, so Fourier series expansion is possible in this particular signal. And if we'll see the example 2, this is t, this particular is x of t. If you have a signal like this, see this kind of a signal is there. So here in this kind of a signal, Fourier series expansion is not at all possible. Not at all possible, because we don't have a finite number of maxima and minima. Okay, and for Fourier series expansion there is another criteria, right? The second criteria, signal should have finite number of discontinuities over the range of time period. In this particular signal we have a lots of discontinuities. Discontinuities means it's not continuous. Continuous means like this is continuous, and discontinuities it's this kind of a things will come, sudden breaks will come. Okay, these things will be known as a discontinuity. So if the signals have a finite number of discontinuities, then it's fine. Okay, so see how many discontinuities are coming in our square pulse. How many discontinuities are coming? This is 0, this is 1, this is 2. Overall time period is this. So this is your time period 2. So in 2 time period, how many discontinuities we are getting? 2 discontinuities we are getting. Here to here 1 discontinuities, then it's going, see this is 1 discontinuities. it's going, then it's again another discontinuity is coming. So total two discontinuities we are getting in time period. We counted this, that's why we are not counting this. Okay, so two discontinuities coming. If you will not count this, then this discontinuities, this discontinuities will be there. So two discontinuities are there. Okay, and the third condition is signal should be absolute integrable over the time range of time period. And the last condition is this: signal should be absolutely integrable over the range of time period. Okay, that is what is that meaning? That is nothing but time period t naught. Absolute integrable means you have to take the mod value dt should come less than infinite. This criteria should also be applied. Okay, like see, this is the signal. This particular is your signal. Yeah, this is t naught by 2, this is t naught, this is 1, this is x of t, this is time period t. So we are getting an absolute value, means this, if you will integrate this, so some value will come, so and that value will be lesser than infinite. So what will the value? Get the area means whatever the magnitude is there, a into t naught by 2. If you will integrate this function, you will get these things only. Okay, just wait. So this kind of a conditions here it's applied. But if I'll give you a signal like example 2, if you have a x of t is equals to tan t, so this Fourier series expansion in this is not possible. Fourier series expansion is not possible. Why so? Third condition will not be applied because it's periodic. This particular tan t is a periodic signal, but you will not get the finite magnitude. Okay, that's why. Okay, there are some exceptions like you can see, if I'll give you the discrete signal, this is the discrete signal, minus t naught, 0, t naught, this is 2t naught. So here all are the impulse function, and in the impulse functions what is the magnitude? Infinite. So although the magnitude is infinite, but in this particular case you will get the Fourier series expansion. Second conditions not follow. See, Dirichlet conditions are sufficient but not necessary. Okay, write it down. Some exceptions are there. Okay, Dirichlet conditions are sufficient but not necessary. Okay, so another example is like you have a particular signal, then the signal is going down, this is the impulse function, this particular is the impulse function. So here also the Fourier series expansion is possible. Okay, how many types of Fourier series expansion is there? So types of Fourier series expansion, write it down, types of Fourier series expansion. types of Fourier series expansion. So we have x of t is equals to a naught plus summation n is equals to 1 to infinite an cos n omega naught t plus bn sin n omega naught t. Okay, so this is the formula of the Fourier series expansion. What is the value of a naught? A naught is actually the DC value. A naught is DC, or we can say average value. Average value of signal. Okay, and what is the formula for getting the average value? It's nothing but 1 upon t naught integration t naught x of t into dt. And what is the formula of an? An is 2 by t naught time period x of t cos n omega naught t into dt. So an formula is this. And what about the bn? Bn is nothing but 2 by t naught time period t naught, okay, x of t, instead of cos it will come sin n omega naught t into dt. Okay, so this is the trigonometric Fourier series functions. What about the complex exponential Fourier series expansion? So complex exponential Fourier series expansion. Okay, so complex Fourier series expansion will be like this: x of t is equals to summation n is equals to infinite cn e power j n omega naught t. So the same thing we can represent like this: x of t is equals to summation n is equals to infinite it's minus infinite to infinite, it's not infinite, minus infinite to plus infinite cn e power j n omega naught t. Okay, and what is the expression of a cn? Cn can be written as 1 upon t naught time period t naught x of t into e power minus j n omega naught t into dt. That's it. Okay, so Cn is just expression of Fourier series coefficient or exponential Fourier series coefficient. Okay, and if you will substitute C naught, means C naught, what you will get? 1 upon T naught.
So we have to remember all these formulas, expressions.
No, you don't have to remember these things. When you will do these questions, it will automatically you will remember. So okay, it means like it's not a very big formula. While doing the questions and all, you will be able to remember those all formula. It's not a very big formula actually. See, I will tell you the breakdown how we are breaking down. Okay, while proving the theorems and all, then you will understand.
Okay.
So C naught is actually 1 upon T naught, means it's like a DC value only, na? Whatever the DC value. See, this is just a DC value we are calculating. This is the DC, means we are integrating the signal. That's it. And yeah. So if you will put the n, so you will get 1 upon T naught, n as a 0. Means if you will put n as a 0, then you will get like this. So it's coming equal to a naught only. So whatever the things we had seen for this particular signal, a naught is equal to 1 by t naught, integration of a t naught x of t dt, same thing we are getting. Okay, actually the meaning is this: e power minus j omega naught t can be written as cos omega naught t minus j sine omega naught t. So see, so here we break down the signal in two form. Here plus is there. So if it will be plus, then this will be also be a plus. Okay, so here we break down the signal in two form. That's it. Formula is same only. Both the things, means like you need, if you remember this formula, you can easily, you will easily get this also, this one also from this. How we'll say now how it's coming. Okay, so yes, C naught we are getting like this. Okay, now if we will put n is equals to minus n, so what we'll get, C of minus n is equals to 1 upon t naught x of t into e power minus, so it will be e power jn omega naught t, e power jn omega naught t. Okay, so this is C of minus n and this is C of n. Okay, yes, and if you will do the conjugate of C of minus n, C of minus n conjugate, if you will do, what you will get, 1 upon t naught integration t naught x of t e power minus j n omega naught t. Okay, so what you understood from this, C of n is nothing but C of minus n conjugate. Okay, see, formula is this, x of t summation n is equals to, forget about the trigonometric formula, you remember this, x of t summation n is equals to minus infinite to infinite C of n e power jn omega naught t. So what is the formula of a Cn? 1 upon t naught integration t naught x of t into e power minus jn omega naught t. This is the formula. If you will substitute n as a 0, so this 0 will become 1, so you will get this formula, and this is nothing but it's equals to your trigonometric a naught formula. And what I am telling you, put the value of a n is equals to minus n. So if you will put the value of a n is equals to minus n, what you will get, x of t e power jn omega naught t. Now if you will take the conjugate of this, C of minus n the whole conjugate, you will get back the same original signal of C of n. So that's why I am writing C of n is nothing but equal to C of minus n conjugate. Okay, but in this case this is also a conjugate, we are assuming. So that's why if x of t is conjugate of, if this condition is satisfied, then only this will be true. If your signal is conjugate symmetry, means real, then only this condition will be satisfied. Real means what? If you will get 2 plus 5j signal, if the x of t value is 2 plus 5j, so x of t conjugate what will be 2 minus 5j. So this is not equal. This particular 2 is not equal. But if the signal will be real, there will be no imaginary term. Even though you will conjugate those signal, you will get the same thing, like 2 value. The conjugate of 2 is same. So when is this formula is applicable? When your signal is real signal. When your signal is real signal. For real signal, write it down. For real signal, exponential Fourier series coefficient will be conjugate symmetric. Conjugate symmetry means C of n is nothing but C of minus n conjugate equal. This is the meaning of a conjugate symmetric. Conjugate anti-symmetric means minus will come. So for example, like if I am giving you a particular signal x of t, see, example 1. If my signal is x of t, that is periodic signal, okay, whose C of n value is given as n square plus j sine n. Okay, so x of t, this C of n value is given, and in the questions it mentions that the x of t is real signal. X of t is real signal. Don't see about these things, but it's given x of t is a real signal. Okay, now you need to find the value. How you will do it? Formula of x of t, any signal can be represented in the form of Fourier series, n of minus infinite to infinite Cn e power j and omega naught t. Okay, now uh, the signal will be something like from minus infinite it will come to plus infinite if you'll put the value. So you will get something c0 value plus c1 e power j omega naught t plus c2 e power j omega, okay, omega 1 means omega t only. Okay, so we are substituting, that's omega t, it's omega naught t, means it's omega naught value, so this is omega naught only, and here what we are putting, n is equals to 1, here what will come, n is equals to 2. Okay, because n is there. And if you'll go in the minus directions, so in minus directions what will come, c of minus 1 e power minus j and minus j omega naught t, because n put the value of n is equals to minus 1 only, like that. Okay, now if you will substitute the value, you know that c of n it's given in a question as n square plus j sine n square plus j sine n. This is given in the question. Okay, what is the value of a c of 1? 1 plus j sine 1. What is the value of a c0? C0 value will be c0, if you substitute the c0 value, so c0 will be c0 means like a c0, so it will be 0 only, n square plus j sine n, if you put the value of a n as a 0 you will get 0 only. What is the value of a c of minus 1? C of minus 1, put minus 1 the whole square plus j sine of minus 1. What you are getting? 1 minus j sine 1. So this is your c of minus 1. Okay, so you got the signal like this, and check it. Is c of 1 is not equal to c of minus 1 the whole conjugate? See, we are getting the same thing only. If you will conjugate this signal, you will get this signal only, because our signal is real signal, that's why this condition is satisfying. Okay, now if you will substitute all the formula, plus c of minus 1 we got 1 minus j sine 1, c of 0 is 0, plus c of 1 is 1 plus j sine 1. Okay, here e power minus j omega naught t will come, here e power j omega naught t. How? Because of this, and if you will take the common these things and these things, like we are getting e power minus j omega naught t plus e power j omega naught t plus e power j omega naught t and j sine minus e power minus j omega naught t. What is the common part? We are getting j sine 1. Okay, now I am doing a multiplication, 2 upside, and here dot 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 terms are there only, dot 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 terms are there only. So multiplying 2 upside, 2 downside, 2 upside, 2 downside. So what is this? E power minus j sine omega naught t plus e power j omega naught t is nothing but 2 to cos omega naught t. Formula means cos omega naught t is nothing but e power j omega naught t plus e power minus j omega naught t divided by 2. So the same things from this we can derive. And what about this? It is nothing but e power, and yeah, so we are getting like this. And if you will break these things, so what you will get? E power, so e power j omega naught t minus e power minus j omega naught t divided by 2. 2 2 only 2 is there, so this j is there, so I'm taking this j is downside, so it's becoming minus. So e power j omega naught t minus e power minus j omega naught t divided by 2j, so we are getting minus sine omega naught t into 2 sine 1. Okay, so see, your signal is anywhere your signal is any j term is present in this kind of a signal? No. If you will further break, if you will further do this calculation, you will not get any imaginary term. So this is your real signal. So we are getting a 1 plus 2 cos omega naught t plus j sine 1 into 2. So this we are getting a real signal only, not imaginary signal. Okay, now you have a question this is the question. This particular is x of t minus tau by 2 to plus tau by 2. Okay, it's going like this. It's going like this. Okay, so time period means like it's given like this. Okay, so if you will break this particular from here to here, so your time period will be minus t naught by 2, and here if you will break, so this will be minus plus t naught by 2. This is your plus t naught. Okay, so I'm taking this part. It's up to your convenience what you want to take. You can take this part also from here to here, but it's look nice. Means we are getting a whole rectangular pulse. That's why we break the signal like this in this form, because the time period will be same only, minus t naught by 2 plus t naught by 2. If you will plus it, you will get the time period same only, same time period you will get. Okay, now the solution means like if you want to find the solution of this in this signal, you need to find the value of Cn for the signal x of t. So what is the formula of a Cn? Cn is nothing but 1 upon time period divided by range of the time period, means minus t naught by 2 to t naught by 2 x of t into e power minus j n omega naught t into dt. Okay, so find the value of a c0 first. C0 will be 1 upon t naught minus t naught by 2 t naught by 2 x of t into dt. Means you are integrating this one, means that is area only. So area, what, how much area you are getting? If you will integrate this particular thing, suppose it's a, or it's nothing, a is equals to 1, so how much value you will get? Area will be 1 into tau. So this is tau by 2 to minus tau by 2 to tau by 2. So what is the range of this? So this is tau, so 1 into tau. This is my time period. So yeah, okay, Now if I want to calculate the value of a cn, this is c0 value. If I want to calculate the value of a cn, so cn is what? 1 upon t naught, t naught by 2 to t naught by 2 x of t e power minus j and omega naught t into dt. Okay, so now put all the values. At what range you have the pulse? Minus tau by 2 to plus tau by 2. So that's why minus tau by 2 to plus tau by 2. And what is the signal I am getting? Suppose I have taken a, so this is a value a. Okay, a naught assumedly. And what is the things? E power minus j and omega naught t only. E power minus j and omega naught t into dt. Integrate this. If you will integrate this, a naught by t naught e power minus j and omega naught t divided by minus j and omega naught will come downside. This value will be minus tau by 2 to plus tau by 2. So a naught, t naught and omega naught t, okay, and e power minus j and omega naught tau by 2 minus e power j and omega naught tau by 2, minus minus becoming plus, that's why I have written like this. Okay, okay, so now we can do the things more clearly. See, a naught we have, and this particular minus I have not mentioned here, minus, and j and omega naught, so j is also there. So we have minus j and omega naught into t naught. Okay, it's multiplying with e power minus j and omega naught tau by 2 minus e power j and omega naught tau by 2. Okay, so how you will calculate this? Multiply 2j upside, 2j downside. So what is the meaning of this particular signal? And e power, okay, what is the formula of a sine theta?
Sine
Yeah, sine theta formula is what? E power
e power j minus e power minus j by 2.
e power j minus e power minus j by 2. Okay, but here minus
2j.
yeah, here minus, yeah, by 2j, but here minus j is there, so we need to take the common.
Take the minus
Yeah,
common.
so we'll get a naught j and omega naught t naught into into sine and omega naught tau by 2, correct? And here 2j is there, so j will get cancelled out. So you are getting what? 2 a naught and omega naught t naught sine and omega naught tau by 2. Okay, so and again you can do one thing I will tell you again. We can break this in the form of sampling function. Okay, sampling function. So how we'll break these things in a sampling function? So what is the formula? Means in a sampling function, this same things will come. Sampling of t. Sampling of a t means what? We had studied the sampling signal, na? So sampling of t means yeah, sync t is nothing but sine t by t. This is your sync t function. But if I am telling about the sampling t function means sine pi t divided by pi t will come. Right, means in the sampling function you are getting the pi functions as a there, means whatever the function is there, you need to write like this. So the same things means go to the previous lectures and see what is the sync function and sampling function, and you will easily convert these things in the form of a naught tau divided by t naught sampling of n omega naught tau by 2. So this is actually, you can leave it up to here also, but if you want to convert this in the form of a sampling function, so just check the what is the formula of a sampling function and sinc function, you can convert these things. Okay, so here some numerator and denominator multiplication is there, upside and downside, to make the signal like this. So if let's check a naught tau t naught into sine n omega naught tau by 2 divided by n omega naught tau by 2, this getting cancelled out. Okay, this is going upside, so 2 a naught t naught and sin t sine t. Okay, and just hold a minute, I it means yesterday we had seen actually I think sin t and sine t should get the result. Yeah, so yes, sorry, I'm really sorry. Sync t function was sine pi t by pi t. Okay, so whatever the functions you are getting here, you are writing that functions, means like, see, if you want to write sync t, that means pi is multiplied with this sine pi t divided by pi t. But in a sampling, in the case of a sampling, if you are writing sampling of x, so sampling of x is nothing but sine x by x only. Okay, no pi will be multiplied, but in this case pi will be multiplied. So if you want to write this function in the form of sampling function, so what you will write, sampling pi t. Okay, so sync t is equal to sampling pi t, because the same functions will be divided by this. And in sync t sine will multiplied with pi t divided by pi t. This is the formula of a, but if I am, but I am telling about the sampling function, sampling t, that means sine t divided by t. Okay, so these functions, what they did, so they want to convert this function in the form of sampling function. So n omega naught tau by 2 we want as in a denominator. So we have n omega naught, we have n, we have omega naught, we don't have tau, so we multiply tau here upside. We don't have 2, so we had multiplied 2 here and 2 here upside. So what the functions extra terms we are getting, 2 a naught 2 a naught tau by, yeah, 2 a naught tau by t naught. Okay, these terms we are getting extra, and now the denominator is matching with this, so we are just writing a sampling functions n omega naught tau by 2. So this the same thing they did, 2, see, okay, so like this way we are finding the sampling function. Okay, I will tell you again, see what I am doing, just wait. Yeah, actually sync and sampling is are a little bit confusing. So means I'm always forgetting means in which I have to multiply pi and so. But if you remember the concept, then it's okay. Mm, yeah. See, so we are getting the function like this: a naught divided by t naught e power minus j n omega naught t. Okay, e power minus j n omega naught t minus e power j n omega naught tau by 2. So here tau by 2, here also was tau by 2, and this was we derived and we got the equation like this: a naught minus jn omega naught t naught minus jn omega naught will be there. So 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 we are getting a naught divided by minus jn omega naught t naught, and this we are getting sine n omega naught tau by 2. So this was the function, and we need to convert this function in the form of sampling function. Okay, and minus j, I think minus j was not there. So 2j will, yeah, 2j multiplied, we had multiplied this 2j. So okay, let's derive it again. We having the function c of n 1 upon t naught. Here I think it's given wrong. Minus t naught by 2 to t naught by 2 x of t e power minus j n omega naught t into dt. This is the function. Okay, means like we have a graph, this graph, and this is minus tau by 2, this is plus tau by 2, and the same thing is repeating like this. So we assume the time period, this particular we had assumed the time period, and we break the time period in the form of minus tau by 2 to plus tau by 2. So this I am assuming minus t naught by 2, and this I am assuming plus t naught by 2. So minus t naught by 2 to plus t naught by 2, overall time period is t naught. This is x of t, and the value of x of t is a, means from this range to this range. If we will, and this will remain the same, if we will integrate this, so we'll get a e power minus j n omega naught t divided by minus j n omega naught t, and this will be minus tau by 2 to plus tau by 2. Okay, now if you will solve it again, a naught t naught n omega naught, this is minus j, I'm keeping like this only. So e power minus j n omega naught tau by 2 we have, minus e power plus j n omega naught tau by 2 we have. Okay, now if we'll take the common, minus common, so it will become plus, it will become minus, and this minus minus will get cancelled out. Okay, clear. Now if I am multiplying 2j downside and 2j upside, this becoming sine, correct, and this j will get cancelled out. So we are getting 2 a naught t naught n omega naught t, and here we are getting sine n omega naught tau by 2. Okay, now if I want to make this in the form of a sampling function, so sampling function, remember the formula: sampling of x is nothing but sine x by x. So this assume this function as a x function, so we want to make this as a n omega naught tau by 2. So n omega naught and this 2 can be represented as by 2 here, by 2. So it will go. So we have n omega naught by 2, but we don't have tau. So I had multiplied tau downside and tau upside. So what I am getting? A naught tau upon t naught sine, this I am assuming as a x function, this I am assuming as x function, so sine x divided by x. So I am getting a naught tau by t naught sampling of x, and x is nothing but x is n omega naught tau by 2. So we got the results. Yeah, this is the correct result. So a naught tau t naught sampling n omega naught tau by 2. So these things can be represented in this manner also. Okay. Yeah. So this is your Cn value. This particular is your Cn value. And if this is a sampling function, so how the signal will be? It will be like this. Cn value will be like this. Like this means you will get like this. These all are the discrete value. A naught tau by 2. It's depending upon the tau value, how much tau value you are substituting. So if I am putting C as a and 1, C as a 0, so this is my C0 value, this is my C1 value, this is my C2 value, this is my C3 value, this is my C4 value, C5 value, like this. Okay. And yeah, so this is real plus even signal. Real plus even. Why real? You are not getting any imaginary term. And why even? Sampling function is a even function. That's why. So real plus even function. And that's why this C, you can cross check also. C of 1 will be equal to C of minus 1 conjugate. Okay. This is C of minus 1. If you will take the conjugate of this, you will get again the same things. Again the same thing you will get. This was the concept, and there are some few topics. Okay. Okay. Now we have another question. That question is very important also. You need to find C of n for signal x of t, and x of t is given as summation n is equals to minus infinite to infinite delta t minus nt naught. Delta function is real functions. Okay. And if you plot the curve, plot the graph of this question, so delta at n is equals to 0, you will get an impulse function. Impulse functions. Okay, delta at n is equals to 1 means at t naught value you will get an impulse function, t naught value. At minus t naught value, delta is equals to n is equals to minus 1. So at minus t naught value, you will get again impulse. So this will be like this, 2t naught, 3t naught, 4t naught. It will go like this. Minus 2t naught, minus 3t naught. So go like this. Okay. So what is the average value of this? Average value means your C0 value. C0 is nothing but C0. What is the formula of a C0? C0 is 1 upon time period minus t by 2 to plus t by 2 and x of t e power minus j and omega naught t. So if you will put the 0, so this will be 1, and x of 0, so integration of a x of 0 between minus t by 2 to plus t by 2 range, what the impulse functions you are getting. And we already know the integrations of any impulse functions is the area only, and the area, its magnitude is infinite, but the area will be 1 only. So 1 upon t naught, and the range is there, so range, because of that range, yeah, so range means like you are getting a 1, so you are getting the average value as a 1 upon t naught value. Okay, at t is equals to 0 we are getting this particular things. So this means like this is the question, and at each and every value means like this is your c of 1, this is your c of minus 1, so c of 1 value is what, this particular area, this particular area. Okay, so cn, if I want to find the value of a cn, the formula for the cn is 1 upon, wait, yeah, formula for the c of n is minus t naught by 2 to plus t naught by 2 x of t e power minus j and omega naught t. Okay, so x of t means this particular value, it's delta plus t naught by 2, it's delta t. Okay, if we are checking, if we are selecting the range here, so it's just a delta t into e power minus j and omega naught t. So I told you, for if the questions will be like this, so we assume like delta t minus 0, so what is the value of a t? T is 0 only, so substitute the value here, so you will get 1 upon t naught e power 0, so you will get the value as a 1 by t naught. 1 by t naught is c of n value, and yes, that's it. So c of n means c of n is representing 1 by t naught only, so we got the equation of a c of n. So each and every means like even your c of 0 will be 1 by t naught only, even c of 1 will be 1 by t naught only, c of 2 will also be 1 by t naught only, all cn is 1 by t naught, that's it. So all c naught is 1 by t naught means this all is 1 upon t naught, that's it. So this questions was asked in 2016 GATE. I means like who conducted, I don't know, IIT Madras or IIT Bombay. So C of n we need to find in this particular question. And what kind of a signal is this? This is real plus even. Now there is a one made easy workbook problem. So in x of t they had given like this, c of k is minus 1 by 3 to the power k, and for k is greater than equal to 0, and 0 for k is lesser than 0. Okay, this is a question. Okay, you need to find the value of x of t. Okay, so x of t In the form of Fourier series, how we will write? Minus infinite to infinite. Here ck, here c of n is not there, so we will also write like that, ck e power j k omega naught t. Okay, okay, this is the formula. Now what you will do, see, for k is lesser than 0, for k is lesser than 0, it's if the value is 0, so we again further break down this summation 0 to infinite. 0 to infinite means from 0 to infinite, if we are getting minus 1 by 3 to the power k into e power j k omega naught t. Now if you will put the value like k is equals to 0, what you will get? 1 value. K is equals to, if k is equals to 1, it will be minus 1 by 3 e power j omega naught t. If k is equals to 2, so 1 by minus 1 by 3 the whole square e power j2 omega naught t, like that it's going. Okay, so we are getting a sum of, this is nothing but this is gp, geometric progression. Okay, and it's going up to infinite. So sum of gp is, if the gp means you need to find the value of r. So check the value of r. So r value, if you want to check the value, this is ar square. So r value is this only. Okay, ar divided by a. So sum of means if you are getting the gp geometric progressions, geometric progression is nothing but series. Means if you want to find the series of the geometric progressions, a divided by a minus r. So a is what? A is 1, a is 1, and r is this, so minus 1 by 3 e power j omega naught t. So if you substitute this, 1 divided by 1 plus 1 by 3 or j omega naught t. So this will be the answer, and you can put the omega naught value as 2 pi. If you will, yes. So this will be the answer, like 1 divided by 1 plus 1 by 3 e power j omega naught. You can put the value of omega naught is what is the meaning of omega naught? 2 pi f. Okay, and if they can ask you the at what frequency we are getting a some particular signal like this, so they will give you the frequencies and all. So if you will put the value, you will get your solutions. Okay, means they are asking a questions like this, at omega naught is equals to 2 pi, what will be the answer? So directly we are substituting omega naught is equals to 2 pi. So 1 divided by 1 plus 1 by 3 j e power j 2 pi t at omega is equals to 2 pi. So you know that this formula, how geometric progressions formula, it's very important, a divided by a minus r. And here one thing is also very much important, your r should, the value of r should not must be lesser than 1, it should not be greater than 1. If r is greater than 1, this formula is not applicable. So we are assuming our r is lesser than 1, and it will be lesser than 1 because whatever the functions you will put here, and it's divided by 3, and like at omega naught is equals to 2 pi, they are asking, so at that value you will get your r value will be less only. So means the range of r should be between 0 to 1. Same question, repeated same questions. Question number 18, workbook. Like they had given x of t, c of k is 1 by 2 to the power k for k greater than equal to 0 and 0 for k lesser than 0. So you have a formula, substitute in that formula and get the result. X of t is nothing but summation n is equals to minus infinite to plus infinite c of n e power j n omega naught t. Okay, if you will again if you will convert this, because we have a zero value, so it will come from 0 to infinite c of n e power j n omega naught t. And now if you will put the value of c0, this c of n represents what? It's 1 by 2 to the power k. 1 by 2 to the power k. K means n only here. So, and if you will put the value like this, what you will get? 0. So 1 will come only. Then 1 by 2, 1 by 2 e power j omega naught t. Then 1 by, then 2, 1 by 2 the whole square e power j 2 omega naught t. Like that this is going. So what will be the answer? Final answer 1 divided by 1 minus r. So 1 divided by 1 minus r is what? R is this ar by a. So 1 by 2 e power j omega naught t. This is the final answer. Okay, and they they can say like this. They can give you the value at find the value at omega naught, some particular at omega naught. What will the value of this? They can ask you like that also. Yeah. So this was means like we had discussed up to mm, let's check. Yeah, just try this problem by yourself also. Then only you will be able to clear this concept. Nothing but we are just substituting on that formula. This formula repeated. They are asking these questions many times. This formula only, and they will give you the value like this. And they will say to transform this in this x of t. Find the value of x of t. You know the formula. You substitute this, and you should know that GP and AP formula. Then it's very easy to solve this kind of a questions. Okay, now if I'll tell you the relationship between a complex and the trigonometric Fourier series, so there is a one relationship also between the complex and trigonometric Fourier series expansion. Okay, so what is the relationship between? The next topic is that only. Oh, let me make in this one only. Okay, so write it down. Relationship between relationship between an, bn and cn. Okay, so what is the relationship between an, bn and cn? Cn is nothing but 1 by 2 an minus jbn. Okay, and an is nothing but 2 real cn. Okay, and bn is nothing but 2 imaginary of c of n. So this particular is the relations. This is relations between an, bn and cn. So for this is applicable for any type of signal. For any type of signal. But these twos are not applicable for any type of signal. Valid only for real x of t. Example, if you will see the example, so x of t can be real plus periodic, can be imaginary plus periodic, can be complex plus periodic. And if an value is given and if bn value is given, these things are given, then they can ask you the value of a cn. Okay, so how you will apply? C of n is equals to 1 by 2 an minus j bn. Using this formula, cn is equals to an minus j bn by 2. Okay, if the signal is real plus periodic, if the signal is imaginary plus periodic also, and if the signal is complex plus periodic, then only we can apply this formula. See, we had seen the formula. What we had seen, x of t formula is summation n is equals to minus infinite to n is equals to infinite cn e power j n omega naught t. This formula we had seen, and actually, and we also know that an is nothing but 2 upon time period, overall time period, x of t cos n omega naught t into dt. For b of n, 2 upon t naught x of t, instead of cos it will come sine n omega naught t into dt. Okay, now in a particular question, it's given like this: f of t signal, that is real signal, summation n is equals to minus infinite to plus infinite 3 divided by 4 plus 3 n pi the whole square e power j n pi t. They are given like this: 3 divided by 4 plus 3 n pi the whole square e power j n pi t. Okay, so this is what, this particular is your cn value. So you know the cn value. So cn value is 3 divided by 4 plus 3 n pi the whole square. Okay, and this signal is given as real plus even signal. And this kind of a value, what we understood from this kind of value, this is also real plus even only, because if you will put the c of as a n is equals to minus n also, you will get the same result because square is there. So this is real plus even. Yeah, now what is the omega naught value? Omega naught value, from C here we have the general formula this, so n omega naught t. So omega naught value given as pi. So we know that 2 pi t naught is equals to omega naught. So what will be the value of a t naught? Omega naught divided by 2 pi. Okay, and what is the omega naught value? It's given pi, 2 pi. Okay. Yeah. Sorry, I'm really sorry. Omega naught is equals to 2 pi t naught, and the value of omega naught is given as a pi, 2 pi t naught. So t naught value will be pi divided by. Okay, so like, or it, yeah, it's like that only. So see, like you have a f of t signal, that is real signal, that the time period is 3 divided by 4 plus 3 and pi the whole square e power j and pi t. So pi t means what? We are we are just comparing this particular two things. So Cn value is 3 divided by 4 plus 3 and pi the whole square. And n omega naught t. So n is not n, and everything is matching. So omega naught value is pi. And we know that omega naught is equals to 2 pi f. Okay. So omega naught is equal to, oh, okay. That's why it's not coming. I had written wrong. So omega naught is actually 2 pi f. So omega naught is equals to 2 pi f. We can write like 2 pi by t naught. So t naught will be 2 pi by omega naught. So t naught is equals to 2 pi by, and the omega naught value is pi. So we are getting the t naught value, that is 2. So time period is 2. Yes. Okay, so we need to find the value of a time period from this particular question. They gave like this, and they said that what will be the time period of this signal. So using this we can find, and they can ask you what will the value of a c of -1, c of 2, c of 3, c of 4. Directly they had given in the question. Okay. Now there is some terminology. Uh, these terminologies are very important. So first, make a table x of t this side and c of n this side. So if you have a real signal, so c of n will be conjugate symmetric. Conjugate symmetric. If you have a conjugate symmetric signal in x of t, then c of n will be real only. If you have an imaginary signal in x of t, then here you will get conjugate antisymmetric. And if you will get here conjugate antisymmetric, then here you will get imaginary signal. If you have a signal of a real plus even, then it will also real plus even. If you have a signal of imaginary plus even, then this side imaginary will be imaginary plus even, so imaginary plus even will be there. And if you have a signal real plus odd, then you will get real plus odd. It will make real as a imaginary and odd will remain odd only. And if you have a signal imaginary plus odd, so imaginary will be converted to real and odd will be odd only. So this is the chart. So that this chart you can remember and you can directly apply. So see, x of t they had given the value of a x of t is equals to 2j sine omega naught t. Okay, so this, what kind of a signal is this? This is imaginary plus odd signal. So if we want to find the value of a c of n, if we'll put the formula in the formula of a c of n, okay, and you can do directly also, 2j sine omega naught t will be e power minus j omega naught t minus e power j omega naught t minus e power minus j omega naught t divided by 2j.
2j will get cancelled.
Yeah, this will be cancelled. So you will get e power j omega naught t minus e power minus j omega naught t. So what is the c of one value? C of one value is 1 and C of minus 1 value is minus 1 and C0 value is 0. Compare this with this particular formula. Summation n is equals to minus infinite to infinite C of n e power j n omega naught t. So here we are getting only two terms. So C of 0 is 0, C of 1, C of 1 is your 1,
Minus.
yeah, 1,
C
1,
of minus.
and C of minus 1 is minus 1.
Yeah, okay.
Yeah, so this is what? This things is what? This is real. This is real, but it's a odd. This is your odd signal. Real plus odd signal you will get. So if you are providing the imaginary plus odd signal, so in the Cn terms you will get real plus odd. Real plus odd value. Odd, why odd? Put, assume x of t is this e power j omega naught t minus e power minus j omega naught t x of minus t. So e power minus j omega naught t minus e power plus j omega naught t, minus common. So you are getting minus common as x of t. So x of minus t is minus x of t. That's why this signal is odd. And why real? Because all the terms are real only after putting the values and all. Okay, we'll continue tomorrow, means like, okay. So today I'm leaving to here only.
Okay.
Just revise those things and all.
Thank you, sir.
Yeah.